Go ahead.
Cool. Hang on.
Yeah.
How the heck do you
You're gonna need it.
I'll figure it out later. All right. Cool. So I'm Yu Liang, and today I'm going to talk to you about interpreting the output of nmap. So I guess first, a little bit of a background. What is nmap? It's short for the network mapper, I guess, and it's a so-called port scanner, which allows you to discover hosts that are on a network. And it was created by Fyodor Vaskovich back in 2001, I want to say. Someone will correct me if I'm wrong. And it'll tell you what ports are accessible on a machine. So I'll get a little bit more into what that means. So before we begin, I would just like to make a disclaimer that you shouldn't be running nmap or any other offensive security tools against any infrastructure that's owned by UF without permission, and you don't have permission. So I want everyone to repeat after me. Ready? I will not run nmap against the UF network. And if I do, UFIT will be very mad at me. All right, you can stop now. Yep. All right. Now that that's out of the way, let's begin. So if you don't already, if you don't have a TryHackMe account already, go ahead and go to tryhackme.com and create an account. I'm going to have you guys doing the lab as I go through the slides, so you guys can like play around with the features a little bit, the features of nmap a little bit as I talk through it. So who doesn't have a TryHackMe account? Great. Well, just if everyone has an account, then just go to that link up there, or you can search for the room further nmap. And once everyone's there, I'll go to the next step. And if you're on Zoom, I only have one screen, so just holler at me if you have a question. Am I crazy? Are there more chairs in here than before?
Yeah, I don't know where those came from.
All right. Who still needs more time to get to the to create a TryHackMe account and get to the room that I have up there?
Is that a real thing?
Is what?
It's not a real thing.
Oh, it's not. It's not a real room.
Just a regular nmap?
It probably is. It's called further nmap, but maybe that's not like the name when you should search it up. But if you type the link in, it should work as of last night.
Sorry, what's the link we need to get to in Try Hack Me?
All right. Can you see my screen?
Yeah.
If you type like the link that's on the screen right now, you should be able to get to the room. If you don't already have a TryHackMe account, you'll want to create an account, and I guess just let me know when you're ready.
Okay. Because all I see is the "What are you trying to tell me?" slide.
Oh yeah. Okay. I see. Okay. So
Oh, okay.
something's being a little weird. Oh, okay. I see what happened. Give me 1 second. Okay. Sorry about that. I see what happened.
No, you're good. You're good.
All right. Can you see the link now?
It says you started screen sharing. I think it's just loading in.
All right. Okay, I see.
It might be because it's proprietary or something, and it's not letting Zoom capture it.
LibreOffice is not letting Zoom capture it.
Yeah, I can see it, Dag.
No. Yeah, I know. Just give me a sec.
Yeah.
That's what I'm trying to do. But
I got it now.
you got it now. Great. So if I full screen it, can you still see it?
Yes,
Okay,
yeah.
great. All right, cool. Sorry about that. Thanks for speaking up. All right, who in person here is not at the room and needs more time?
You say 4-4. It was always 4-4.
Make sure you're logged into the TryHackMe. Like you make an account and log into the account, and then check to make sure you didn't type the link wrong. It's tryhackme.com/room/further nmap.
It keeps redirecting me to the welcome. Is there any way to like bypass the first thing, or should I have just answered like I don't need that?
If you don't have an account, you might need to make an account to be able to use the room. It's like a free sign up.
No, yeah, I made an account. It just keeps redirecting me to the learning path. Like,
Oh, just click through that. Skip
okay.
if you need to, or I forgot what like the onboarding process is like.
Okay, got it. Thank you.
All right. I'm probably gonna get started, but if you need more time, or I guess when we pause for like you to like do stuff in the lab, I can help you out if you need more time. All right. First, I'm gonna give a brief review of the networking lecture last Thursday in case you weren't here for that. So the networking protocols are organized into a type of stack where every protocol that's higher up on the stack is kind of inside every protocol that's like lower down. And we do this because every layer is meant to do one job and do it really well. And you don't want to have to worry about the other layers when you're working in a specific layer. Nmap will mostly be concerning. Well, Nmap will mostly concern the transport and network layers, which I'll get into a little bit more. And there's been new features added where Nmap can like scan everything from like top to bottom of the network stack, but its core features are in scanning services at the transport and network layers. So there's three things that a server can do in response to a connection request. The first thing is the server can agree to do what was requested, and usually in Nmap, this will be represented by open. The second thing that the server might be able to do is the server can politely refuse to do what was requested, and Nmap will show this as closed. And the final thing that the server can do is basically give you the silent treatment, and that's shown as filtered in Nmap. So by silent treatment, I mean you send stuff to the server and the server just doesn't respond. We'll start at the internet layer, which is this layer is where packets are routed to their destination. And examples of protocols at this layer are IPv6 and IPv4. And the most important thing that you need to know is this is a layer at which debug things at the internet kind of happens. And the packets here will contain a source IP address and a destination IP address. and other unimportant stuff that we don't really care about for the purposes of this lecture. So let's do an example of what happens when you send a packet. When you try to send a packet to a specific destination, on the diagram at the top, we'll pretend that your IP address is 192.0.2.110, and you want to send a packet to 203.0.113.242. It's going to go through some number of routers in the middle, and the routers in the middle can choose to do certain things to your request. So who remembers what the first thing that a router will be able to do? What one of the things that a router will be able to do in response to a request is? I said that 2 slides ago, and it's also up there. Come on, I need some participation. What's the first thing that a router might be able to do?
Check the port.
All right. I'll give you a hint. Most of the questions I'll ask today are readable off the slides. So, all right.
It forwards the packet.
That's correct. It will agree to forward the packet. So you'll send a request that's bound for a specific server, and the router will get it, and it'll decide to. It'll say this packet is fine, and it'll forward the packet on to your destination, and your destination gets the information that you wanted to send. Now, on the left here is an example of the command ping. I was sorry if the text is a little small. I didn't realize. But anyways, so I hope you can see it in the back, but if not, I'll post these slides. But on the left here is an example called ping, and that is a command usually used to debug network connections. And this is what happens when you ping a server and the router forwards the packet onto its destination. So essentially what ping does is it sends packets to a specific destination and it says, please reply to me. Please reply to me as fast as you can. And this is what it sees. It'll get the packets back from the server and everything will be okay. And on the right is what nmap is what happens when you nmap the server. Now, the command that I use here has a few, I guess, sort of flags on nmap, a few different things that it'll be able to do. So the first flag is disable ARP ping, which is not really important for the purpose of this. There's some automatic scans that nmap tries to perform no matter what you do. So this is for demonstrative purposes. I put that part in. There's another flag which would be important, and it's the tag PE flag for nmap. And this flag, what it does is it'll have nmap run a scan. Basically, it'll have nmap do the same thing that this ping tool is doing up here. And it's meant to check whether a remote computer is online or not, or if it's reachable or not. And the last argument of the nmap command up here is just the IP address. And you'll notice that I ran the nmap in this case with a prefix of sudo, and that means run it as the administrative user. And that's because nmap does some low-level operations with packets that you would need administrative privileges on your machine to be able to do. Oops. All right. So what's the next thing? What's another thing that a router will be able to do if you try to make a connection request through it?
Declines to forward the packet.
That's true. It can politely refuse to forward the packet. And in this case, you would send a packet to the router, and the router will say, sorry, no can do. And it'll send back what's called an ICMP destination host unreachable. It's basically, all of this is happening at the internet layer, as I mentioned before, but your local router is going to say, it'll send this message, and what it'll mean is it either means that this packet, or it either means I'm not sure how to get to this IP address that you specified because maybe the router is not connected to like the entire internet. It's just like a forwarding stuff between like local area networks, or maybe it's sending back this response because it doesn't want you to access whatever host is behind it. This could also be sent as like a sort of firewalling mechanism for security purposes. But basically, it's the router politely refusing to do what you asked it to do. And on the left here, I've run the same ping command, but this time the router returned these packets. And if you take a closer look, you'll notice that the response isn't actually from on the ping command isn't actually from the host that you were trying to send it to. In this example, I was trying to send the packets to 10.0.0.1, but a router in the middle of the connection, the 192.168.75.1 router, replied to me and says that, no, I'm sorry, I can't fulfill this request for whatever reason. And on the right is what is me running the same command as, but through nmap. And nmap doesn't have as granular of output, or I guess as specific as output. So all nmap says, it says the hosting's down, which means nmap couldn't get to whatever address that you were trying to scan. And what's the last option for what a router would be able to do?
It could not respond at all. It could be a silent.
That's correct. The router could silently refuse to do what you asked it to do. And whoops. You would send the message to the router, and nothing else would happen. The router will, I guess, in this case, you don't even know that there's a router there, unless you like send some other packets. And on the left is what it looks like when you run the run the ping command. You'll see that there's no responses received from anywhere in the ping command, and that's because the router didn't respond with anything. And since the router didn't forward your response on, nobody else could respond with anything. And on the right, what nmap sees, it basically gives the same message as it did last time. It'll say, we couldn't reach the host, so we're going to assume that the host that you're scanning is down. So now in the Try Hack Me room, if you haven't already, you want to hit Start Machine. I think it's in the top right corner, and you'll want to try to run this command against your machine and see what you get back. In place of the IP, you'll want to put the IP address that Try Hack Me gives you to, I guess, experiment. The first question that I have that you might be able to answer before running the scan is what does this command do? Like, what is it doing? I kind of explained that a little bit before, but can someone tell me what this nmap scan up here does?
It checks if the host is up.
That's true. It'll check if the host is up, and it performs an, I guess, internet layer check. So right now, nmap is not checking any ports or whatever. We're still like one layer below that. So nmap is only checking if the host is up at the internet layer level. And I guess whenever your scans finish, let me know what you guys see.
It says host seems down.
It says host seems down, but Try Hack Me told you it was up. I wonder what that's about. Well, getting into that a little bit later on. But this is the most basic type of scan that nmap kind of does. And in fact, as I've shown you before, you don't even need nmap to perform this type of scan. You can just use the ping command, which is available by default on Linux hosts, so you don't even need to install nmap to be able to do that. And the host appears to be down, and we'll get into why that is in a little bit. Now, before we continue, is anyone having trouble with Try Hack Me at the moment? So everyone was able to run the command up there and get the message that the host was down. Okay, let's move on. So now we're going to kind of build on top of what was in the internet layer. So the internet layer was all about whether your packets can get to where they're going. Now we've kind of abstracted that away. So pretend that instead of it's you going through a bunch of routers on the network to wherever you want to go, it's just you and whoever you're talking to. It's only you and the server at this layer. Hope that won't take on my display. Okay. And this layer is how processes on each machine kind of communicate with each other. And these at this layer is where some protocols you might have heard of, like TCP and UDP, exist. And the packets at this layer are going to contain port information, which a port is essentially like an address on your machine for whatever service is running on your machine. So if you go to port 80, a lot of you will know this, but if you go to like port 80 on a server, what's usually on that port? Anyone?
HTTP.
Yep, HTTP, which is web traffic. And the packets here also contain a checksum, which we won't really worry about because it's not really important to how nmap operates. But if you're curious, that's part of how the integrity of the information is maintained in the packet. The first protocol that we're going to go over is TCP, and it offers a lot of niceties over what's below it. So on the internet layer, what I had mentioned before is that the delivery of the information is not 100% reliable. So you need something on top of that to make sure that you have reliable delivery of information. TCP is kind of what ensures that your information gets where it needs to go. And yeah, like I said before, the packets contain a source port and a destination port, but it also contains some additional information for the purposes of reliable delivery. And nmap is going to use this information to kind of probe whether a host is online or not online, or whether there's something on a specific port on a host. And remember, a port is just an address associated with a specific host where specific services might listen. And TCP also does a lot of unimportant stuff for us, at least, like congestion control. So I'm going to go over a little bit about how the TCP connection is initiated. And this is basically what nmap kind of exploits to be able to check whether there's things listening on a server. So we'll pretend it's you and the server. There's more than likely, there's going to be routers in the middle. But remember that routers were one layer below, so we kind of abstracted that away. In this situation, you can just pretend that it's you and the server that are directly connected to each other and talking to each other. So first, you're going to send a packet with a flag known as SYN. And all you really need to know about SYN is it's basically you saying, hi, I would like to talk to you, to the server. It's like the beginning of a polite conversation. You can think about like a greeting. And let's pretend that you're going to send it to the server to let's say port 80 on the server. The server is going to reply with a SYN ACK. So an ACK stands for acknowledgement, and SYN, I actually don't know what SYN stands for. Someone will be able to tell me when you Google sync.
Yeah.
Well, anyways, the server's going to send this in, and it's kind of the server's greeting to you. So the server's going to get back to you with this SYN ACK packet, and it's going to say, hey, I'm alive. Or I guess not quite the server, but the service on port 80 is going to say, I'm alive. I'm here to whatever port that you were sending your request to the server. And finally, in a normal TCP connection, you will send another acknowledgement for the server's acknowledgement, and that'll say, basically, I got your message that you got my message, and now we can begin like a conversation. And afterwards, there's a lot of other functions of TCP that it'll kind of like auto adjust the rate where it sends information. But again, that's not quite important for this because all nmap does is it exploits this initial connection request. So let's say that you're want to know whether there's something listening on a specific port, maybe port 80 on a server. What nmap will do to try to kind of find that out is it'll first send a SYN packet to port 80. Now, if you kind of think back to before, what is one of the things that a server would be able to do in response to this connection? Come on, these are the easy questions. Everyone should be answering in unison. Yes, it will accept the connection and it'll respond. So the server will respond with the SYN ACK packet, just like the protocol is kind of requires the server to do. And after that, nmap will kind of ghost the server for speed and also stealth, because if a connection is not completed, generally the information from the connection doesn't go into the server's logs, although some advanced firewalls will probably do this nowadays. We'll probably log the connection anyways nowadays. And also for speed, because if you're sending extra packet, if you're sending the extra acknowledgement packet at the end, it'll slow down the rate at which you'll be able to probe other stuff on the network. And so this is what happened. And on the bottom, I have a scan, which is an example of that. I use the command sudo to run as administrative privileges, nmap, and then tag pn. Now, this flag is very important because when everyone scanned your host on TryHackMe before, the host nmap thought it was down, and that's because the host wasn't responding to the standard "Are you alive?" request. But this flag, the tag capital P lowercase n flag, is a quite important one, and you'll use this when you kind of scan a host and you're a little bit suspicious that it's not actually, and well, you scan a host and nmap tells you that the host is down, but you're a little bit suspicious of that response. You think that maybe the host is just not responding to the standard ways that nmap checks if a host is online, and you want to do a little bit of extra probing. If you put this flag in, nmap will scan the host, pretending that it's up, and it'll give back whatever results that it finds from that. So you want to have that flag. And then the next flag I have in there is tag P. And what that does is it specifies a specific port to scan. You can omit that flag to scan the top 1,000 ports on a machine. But if you have that port in, I put that option in because it'll speed up the scans a little bit for the purposes of today. And finally, there is a tag SS, and this tells nmap to use a TCP SYN scan, the scan that we discussed today. I believe that's the default type of scan, but as you'll see a little bit later on, there are also other types of scans that you can do in nmap. So now that we scanned essentially what we did is had this conversation with the server. So we run this command, and that had this conversation with the server, and it returned a result of open, which, as you'll remember, is what is usually associated with when the server accepts the connection. And nmap knows that it's open because nmap knows that port 80 is open on the server because it got this response back. Now, you already know what I'm going to ask, but what's another thing that a server could do in response to a connection request? Yes, it can politely refuse it, which is basically it'll refuse it, but it'll tell you that it refused it. So same exact scan, same exact nmap command as before, but this time the server did something different. You'll send a packet, a TCP SYN packet to the server, and the server will send a TCP RST packet. Now, this packet usually means, well, I guess this packet is supposed to mean abandon the connection because I'm not ready for you or something has gone wrong, and it's used to kind of close and also refuse TCP connections. So this is the server politely telling you to go away. But if the server does this, nmap runs the scan, and you'll see that it has the port has a status of closed. So we scan port 4444 in this case, and nmap will know that more likely than not, or actually almost definitely, there's nothing listening on port 4444, or it's just not accessible to you. And you do that, and nmap will know that the port is closed. What's the final thing that a server could do in response to the connection? That's correct. The server could refuse a packet silently, which is basically not respond to it. So same scan as before, but nmap will send a packet out to probe to see if it's alive, and it won't really be. I guess it doesn't receive anything back, so it'll be. It's at this point, it's not actually quite sure if the server is up or not. So what nmap will actually do is it'll send another packet out to probe the server again, just in case the first packet got lost. Because if you remember back to what I mentioned a while before, the internet is unreliable. So sometimes there will be there will be like random information. There will be like sometimes randomly in the internet, information will get dropped or like just not delivered to its destination. So nmap will send 2 requests out to kind of see if to kind of like cover the case where the first request maybe didn't make it through. And after the second request goes, after the second request goes and nmap didn't receive anything back, it'll presume that the port is filtered, and that's what is shown here. And yeah, basically, filtered means that the server never got back to you. So now, in your try hack me boxes, I want you to run this command up here. So I guess the first question is, what does the PN flag do? Can someone tell me? Yes.
It doesn't send the thing command, essentially.
Yes, it'll assume the server is up without probing it at all for whether it's up or not. It'll just say, I'm going to scan the server no matter what. And what does tag SS do? Someone else.
Sin scan?
Yes, a SYN scan. And remember that a SYN scan is associated with TCP, which is the kind of, I want to say the most commonly used transport layer protocol on the internet. And so usually like you browse the web, if you're like sending email or like transmitting files, more likely than not, you'll be using TCP. And what does a tag P443 do?
Specify support.
Which is,
443.
that's correct. And I guess a little bit of trivia, what's usually on port 443?
HTTPS.
That's correct. It would be web content. So after you run this command, what do you get?
Filtered.
Filter. So now the question is there a service listening on this port?
Oh wait, no, I put the wrong one. That's filtered.
All right. So if it's filtered, I guess, is there a service listening on this port is the question.
Probably not.
That's correct. The answer is, in fact, probably not. But you can't be 100% sure because remember what nmap did to scan it. And this is going, I guess some people might say, well, it could be firewalled off, and that's true, but we'll just pretend that being firewalled off is essentially the same as the service is not available. The reason the answer is probably not is because, like I said, the internet is unreliable, and all nmap really did was send 2 packets at the server and basically saying, hello, are you there? Like twice. But maybe because of some unreliability of the internet, both the packets happen to not make it through. And so if you're getting filtered responses on specific ports and you're a little bit suspicious of those responses, the best thing to do in that case would be to run the scan again. And it'll give you more confidence in your result that there's really nothing listening at the port. And this is part of the reason why a lot of systems administrators try to configure their systems to not respond to unexpected packets as opposed to politely refusing them, because it gives the attacker the least information possible. So filtered means more likely than not there's nothing listening, but you might want to scan again if you're a little bit suspicious of the response. All right. So let's do that again. Same command, but this time try it with port 80. And, well, I guess we already went through what the command does. And we already went through what is usually on port 80. But the question is there a service listening on port 80?
Yes.
Yes, there is, because you got an open response. And an open response is like, you're almost 100% sure that there's something there, as opposed to the filtered response, which is probably not. And if you still have the information from the previous scan, did this scan take longer or shorter than the previous scan?
It seems like the same.
It might be the same for some of you because you're only scanning one port and it's going really fast. But it should have taken a little bit less time because nmap only had to send 1 packet and get a response back, as opposed to sending 1, waiting for it to time out, and sending another one. And yeah, that's another reason why systems administrators like to not respond, because it slows down network scans, even by like a little bit, and it's just a little bit of extra defense for the network. All right. I guess the last protocol that we'll go over today is UDP. This is like the bare bones program, the bare bones protocol of the internet. And basically, you're like sending information off, and you're not even bothering to have a polite conversation. I've heard it described as like a fire hose of information. So you take like, I don't know, yeah, you take a hose, you point it at wherever you want it to go, and then you like just spray it at them, and then hopefully they'll get as much of it as they need. And because of this, because of how like stripped down it is, it's really fast, which means it's preferred for things like maybe streaming videos or making calls over the internet. But another part of this is that it doesn't have all the reliable connection features that TCP has, and because of this, you get a lot less information through UDP. I have up there that the UDP packets contain source port, destination port, the packet length, the checksum, and well, I guess I missed one, but the data of the packet, and that's it. There's no other features that UDP provides. Everything else is like, hopefully your data gets there, and that's about it. So because of this, it's hard to know what happens when a UDP scan happens. So in response to sending a UDP packet, what is one thing that the server can do? I promise this is the last time we'll be doing this. So come on, I need everyone's participation right now. Yes, it'll accept the packet. And you'll see that essentially just send a UDP packet to whatever port on the server. And this is what would happen when you use a UDP scan through nmap as well. Nmap kind of just sends some data at the server, but it's not really sure what happens. And that's why in here, the state of that nmap shows the server as is open, I guess, or filtered. And that's because there's just not enough information in the UDP protocol for nmap to be able to accurately gauge whether there's actually something listening there or to receive the information, or if there's not. And like I said, you're pointing the UDP protocol, you're pointing like a fire hose at the recipient, and you're just like turning it on, but like you're not getting any feedback back. So whether they got it or not, nmap isn't sure about. And because of that, it's the exact same as what would happen if the server silently refuses the packet from nmap. Nmap will send the packet to the server, and that's it. I mean, the server doesn't get back to it either case. So nmap isn't sure if the port is, or if there's something listening at the specific port or not. Oh, and I guess I forgot to mention this in the previous slide, but there's a new flag that was used here, which is the tag SU flag. And this flag in nmap, it tells nmap to perform a UDP scan. Pretty easy to remember, U for UDP. But yeah, as you can see, when you scan it with the server silently refusing the packet, it's the exact same response as if the server had accepted the information. You really just don't know. And last thing the server can do is to politely refuse the packet from nmap. And in this case, you actually know that there's nothing listening at that port, because what will happen is nmap will send a packet to the server, and the server very politely will say, there's nothing here. So and it'll respond with an ICMP port unreachable message. And in this case, when nmap scans the port, it'll properly say that the port is closed, even for UDP. This is quite unusual, as like I mentioned before, systems administrators usually like to give you the least information possible, and if they just tell their machines to like not respond to anything that like you send at any UDP information that you send at them unsolicited, it's very, very hard to know whether there's actually something listening on the port or not. And for that reason, UDP scans in nmap, they're like super slow. Like a TCP scan, you can scan there's like 65,536 ports on a machine. You can scan all of them in like, I guess it depends on your network speed, but you can probably scan all of them in like 5 minutes at most. But for a UDP scan, it can take hours and hours and not finish. And even when it finishes, you probably won't get much information out of it, because it'll just say that everything's open/filtered. Unless there's some like unusual configuration going on. Oh my god. I don't understand why this computer has to be on for the HDMI to work.
How do we, man?
whenever it comes back on. There we go. All right. So, so yeah, this is like an unusual circumstance, but if you get this, you know for a fact that there's nothing listening on whatever port that you just scanned. So yeah, nmap will know that the port is closed. Okay, never mind. Okay, cool. So one last thing that I want you to do is I want you to scan port. Well, use this command up here, and I guess just as a brief review, what does the tag su flag do for nmap?
UDP scan.
That's correct. It does the UDP scan. And once you scan it, is there a service listening at the port?
This is open.
You don't know, right? You don't know if there's a service listening on the port. Now, let's adapt that command a little bit. Change port 68 to 53 and see what happens.
Open domain.
That's true. And nmap knows that it was open somehow. How did it know? Well, the thing is, on port 53, usually, well, I guess, first of all, does anyone know what usually listens at port 53?
Yeah.
Yep, DNS, the domain name service. It's something that's used to resolve names like that are easy to type, like ufl.edu or google.com, to IP addresses, which is where like the computer is located on the network. And nmap knew it was open because nmap tries to be a little bit clever about how it scans. So because the makers of nmap know that UDP, if you send information, more likely than not, you're not going to get anything back. So they try to give you a little bit of extra information by sending known, I guess, kind of like known protocols at the server. So when you scan port 53, nmap knows that usually there's a DNS server listening on that port. So what it did is it sent like a valid DNS request to the server and hopefully hear something back. And if it does hear something back, it'll know that there's something there. But like I said, there's like a very short list of protocols that nmap will do this for. I think it's probably somewhere very deep in their documentation. So usually when you do a UDP scan, you won't get much information out of it. Usually everything's open and filtered, except for very specific cases like DNS. So when you're trying to find out what's on a machine, maybe you want to scan UDP, but only port 53, just to check if there's a DNS server on there. Because like anything else, it's just like you're spending a lot of time and probably not getting much response. And yeah, that's it. So any questions? Cool. Thanks, guys. I appreciate your participation. Although I want some more enthusiasm. I know it's like 6 o'clock on a Monday night, but we need a little bit more energy in here.
Okay. Stop the recording.
Yes.